this is a continuation of yesterday, but now we're going to get a little bit more complicated. Sinusoidal just means wave. Doesn't mean the sine function. When I talk about a sinusoidal equation, I'm just talking about a wave graph. So just to go through the letters again, A tells us our amplitude or our vertical stretch. B is used to find the period. B isn't the period. C is your start point on the horizontal axis. And D is your median. You can find your amplitude by taking your max minus your min and dividing it by 2. To find your median, take your max plus your min and divide it by 2. And B, if you need to calculate B, you're going to take 2 pi and divide it by the period. If you have B and you need to find your period, it would be period is equal to 2 pi divided by B. Just a rearranging of the equation. Nothing really crazy. C, define the shift per sine. Locate the median or the midpoint of the period. And the midpoint should be headed towards what? So on the regular sine graph, you start at the median and you head towards what? X. Now, if it was a reflection, you'd still start with the median, but you'd look for where it's heading to a minimum. And if it's a cosine graph, you're going to locate your maximum. Easy peasy. That's all from yesterday. So you guys know that. So we're going to write an equation for this graph. So it says write an equation of the function in terms of sine. So as soon as it says sine, I'm looking for the median, the very first median. So first positive median for my starting point. That'll give you my C. Sine's going to tell me I'm looking for a median. I'm going to rewrite this for cosine. So I'm going to be looking for my first maximum. So a lot of people, if I don't specify, I'll take either sine or cosine. Like if I said, just write me an equation for this graph, and I didn't specify sine or cosine, I could take both of them. Okay. So we need to find our things. So we need to find out what A is. We need to find out what D is. We need to find out where our shift is. And we need to find the value of B, which means I have to find my period. Yeah, I have a hard time with letters. Okay. So what's my max? My max is 4. What's my min? What's my minimum of this graph? 0. Okay, if you know your max and your min, you can find your amplitude and you can find your median. So how did I find my amplitude with that 2 pieces of information? Is it add or subtract? So on your very first page. What am I doing with them? Am I adding or subtracting them? Subtract. So I'm going to take 4 minus 0 divided by 2, and my amplitude is 2. So I know my A value is 2. Now I'm going to find my median, which is my D value. So that's 4 plus 0 divided by 2, which also gives me 2. So that means at a value of 2, I'm at the physical middle of this wave graph. So it's a height of 2, a depth of 2. Height of 2, it's depth of 2. That looks all right. So before I go ahead, I'm going to check some things so I don't waste my time creating an equation with wrong information. Okay, what's the period of this function? period of the function. Period of the function. 2 pi over 3. I'm going to look for a max to a max, but that's kind of going to be ugly. So I'm actually going to start at 0, which is a minimum, and go to my next minimum, and that's 2 pi over 3. So the period isn't the same thing as the b value. I'm going to do some math to find it. So in order to find the b value, it was 2 pi divided by the period. So what's my b value? Here. All right. Now, well, I've written a bunch of information and no equations. Awesome. So now C is going to change whether C matters. A, B, and D don't matter if it's not sine or cosine. They're going to be consistent. C matters to what type of equation I'm writing. So that matters. And the only thing that matters at sine cosine. So it said to do a sine graph first. So sine, I'm looking for my first median, my first positive median. Where does that occur? Pi over 6. It occurs halfway between 0 and pi over 3. This would be a measurement of pi over 6. That's half of pi over 3. So the first time I see a median, a positive median, is at pi over 6. That's for sine. So my equation would go like this. Y equals A, which we said was 2. Okay, sine, and then my b value, which we found out was 3, bracket, I need another bracket. My x value, and I need a positive pi over 6, so it's going to be minus pi over 6, close bracket, plus median. That's my part A equation. Part B asked me to do it for sine, or for cosine. So cosine, my C is going to change. Where's the first positive maximum? Pi over 3. So now C has a value of pi over 3 for a cosine graph. Hey Matthew, if you gave me negative pi over 3 for your C value, would that be incorrect? No. No. You could pick pi. You could pick 5 pi over 3. All of those would be a correct answer because it's a cosine graph and it has arrows saying that it's continuing on forever. But it's more mathematically grammatically correct to pick the very first positive one you see. But if you picked a negative one, it wouldn't be the end of the world either. You'd have a perfectly, I would not deduct any marks. So this one would be y equals 2. Cos 3 stays the same. The only thing that changes is my shift. And now I'm at a positive pi over 3. Close my brackets. Plus 2. So A, B, and D stay the same, no matter what trigonometric function you're using. It's your shift that will change based on what trig equation you're using. Easy peasy, right? Okay, so easy. Do it. That's mean. Mean of me. Oh, what did I do? So d value, my max is a positive 1 plus, right? Negative 3 divide by 2 So I'm going to have -2 divided by 2. So this was yours, Carlene. This would have been bracket 3 bracket x minus pi over 3 bracket minus 1. That's a good answer too. Yeah. Oh, you're right. So mine's wrong. I got it wrong. Carlene got it right. I got it wrong. How can I make mine right? How can I make mine right? Mine's wrong. Make it a negative. So I can make my amplitude negative. Why is mine wrong? Blaze is right because my median was headed towards a minimum. And that's not. That's not what you had. We're a team here. So to make mine right, all I have to do is add the negative to it, because I'm a median headed towards a minimum, and we know that in a sine function, it's a median headed towards a max. So Carlene, you got it right, I got it wrong. Where would be the next time after Carlene's that would be not a reflected one? Where would be the next time I see a median headed towards a max? Hi. That would be my next answer, right? Or I could have used this median back here at -pi. So there's lots of answers that we could have done. I'll try not to screw up the next one, but I probably will anyway, because that's how I roll. So for cosine, I'm looking for my very first maximum. That was a little easier to see, hopefully. So cosine is going to be y equals 2 cosine. Do you know how many people get that wrong? Putting the wrong, like I say, write an equation for cosine in terms of cosine, and they do everything right for cosine, and then when they write it in, they write sine. I would call that a transcription error. Some people might argue that it is a full concept error. That's the difference between a half mark and a full mark. Hopefully I'm feeling nice and generous that day. That's pi over 2, by the way. How can I write this as a reflected graph? So I put the negative, but what am I looking for then for my shift? My first min, where's that going to occur? 5 or 6. So here's the thing, it sucks being the teacher in this unit because there's lots of correct answers. So I have to know my stuff and not mess it up. Did I mess that up? I have a minus. Did you write down plus? Yeah. Okay, good enough. All right. We all make some mistakes. Me as well. All right, so that's pretty easy. At least I say that. That's pretty easy. Now we're going to do word problems. Not so easy. Yeah. So now I really going on. So I will tell you sinusoidal functions are really good with tides, and if you don't live by the ocean and haven't experienced a tide, it's pretty cool. Also moon cycles, things like that. Electricity flow oscillates in a wave pattern. So you'll find that most of these questions are around tides. So let me tell you about tides. You have 2 high tides a day and you have 2 low tides a day. Okay, these are things that we just know on the coast where I grew up, so you're supposed to know this. Yep, tidal force, but tidal force are different than tides. Tidal force is when the tide comes in and it's a standing river of water. Like the river is flowing this way, the tide is flowing this way, and the bore is a section of water of waves that as a bore. It's super fun. You take zodiacs out of it and you go crashing through them. It's super fun. So bores are good, but they do create a big section of sine waves. We're just talking about tides. So as the moon rotates around the earth, it pulls the water in and out, and that's what gives us tides. So Prince Rupert, BC has the deepest natural harbor in North America. The depth in meters, the berth of ships can be approximated by this equation, where T is the time in hours after the first high tide. That's kind of important, because that's going to tell you what we're going to be dealing with. Graph the function for 2 cycles. You guys did this yesterday. You have a fancy graph from just a basic equation. So what do we need to know? What do we know my amplitude is? 8. What do we know my median is? 12. So we know that I'm not going to have any negatives here. This would mean the water would be below ground. I'm not sure how that works. 2, 4, 6, 8, 10, 14, 16. That's not going to work, because 12 plus 8 is 20. I tried to go. 4, 8. 4, 8. We can do that. We can do that. 4, 8, 12, 16. So we're going, each tick is by 2. Now I like to put my lines on there, so I know my median occurs at 12. I know my maximum will occur at 20. When will my minimum occur? Will it occur at 2? Okay, so 12 minus 8 is going to put me at 4. So this harbor, you never see the actual seafloor. This harbor, you actually never see the actual seafloor. True, no sharks. Bonus, those lake sharks are. All right, so we know that. What's the next thing I need to know? What do I need to do my x-axis increments? My period. So if I'm going to calculate my period, so my period is equal to 2 pi divided by pi over 6. So the period is, what is it? 2 pi times 6 over. Every time I try to write over here, so what's the period? 12. 12 what? Nope. Hours. Because the period is our x, but in this equation it's t, and it says t is the time in hours. That makes sense. The period of time happens twice in a day. Days are 24 hours. Makes sense. You can't assume that though. You have to actually do the calculations, because sometimes they get really fancy and do like 12.2 or whatever the actual day works out to be. So we know that my period happens 12 hours. So what's my something happening point? What do I do with that period? Right, I take my 12 and I divide it by 4, and every 3 hours, something happens. Okay? Something happens. One wave comes every. Okay. So how are we going to do this? Can we do 1, 2, 3, 4, 5, 6, 7, 8, 9? Ooh, I am not going to get 2 periods on here, because the question says graph the function for 2 cycles. We just can't do the question. Really? We should just move on. Actually, 3, 6, 9. Oh, I can do it. I'm good. 3, 6, 9, 12. Oh, I'm good. 3, 6, 9, 12. I was going up by ones, which made no sense. 15, 18, 24, 30. All right? Okay. I got that happening. Where does this graph start? Where does this graph start? Is there a C value? Is there a C value? Every second one is 3. It's a 24. Oh, Doug hit 21? 21 is overrated. It's kind of like a 5 a hangover. I'm just too excited. I did all my math yesterday. I got nothing left. Is there a C value? Is there 2 sets of brackets here? So is there a C value? No. So is there any shift in the graph? No. So where does my cosine graph start? At 0 time, at a maximum. So we are at high tide. We are at high tide at 0, which we said was 20. So there's my first point. And we said every 3 hours, something's happening, and my increments reflect that. So at 3 hours, I'm at a median. At 6 hours, I'm at a minimum. At 9 hours, I'm back to a median. And at 12 hours, I'm back to a max. That, ladies and gentlemen, is our first cycle. The question asked me to graph 2 of them, though. So I got to keep going. That 21 is very handy to have in there. All right, so I can put arrows on this because chances are this is going to continue. So my arrows have to be pointing the right way. How come I have arrows in negative time? Normally I don't like that. Why can I have negative time? Yeah, we can talk about yesterday. Right? We talked about yesterday. So negative time would put us into yesterday, and we probably would have data from that. Oh, normally we're not time travelers. I know. You're just being wild and crazy. All right. What's the period of the tide? We needed that already. Period of the tide? 12 hours. Did that. An ocean liner requires a minimum of 13 meters of water to dock safely. Determine the number of hours per cycle. I'm going to draw a line here. Anybody know why I drew that line? This is a cycle. This is a cycle. So I need at least 13. I need at least 13. So that has to occur here and here. It can't dock in 12 meters of water. It's not deep enough. It has to be 13. Could it dock in 20 meters of water? Yes. It could dock in 18. It could dock in 16. It can't dock in anything less than 13. So that's why I'm looking at these sections here and here. So there's only certain parts of the day that this can happen. You ready? We're going to do some math. It's going to be super fun. So part C, I need to find out when is it that I hit 13 meters here, and when is it that I hit 13 meters back? What do we know about parabolas? What makes them beautiful? They're the same on each side. They're symmetrical, right? That's why they're beautiful. And that's the same with sinusoidal graphs, as they're beautiful because they are symmetrical. So what we're going to do is we are going to, my equation, I hand again the equation. What's the depth that I need to be at? 13. So I want to find out where my graph hits 13. 8 cos pi over 6 t plus 12. That was my equation. Yes? All right. We're going to solve it. We're going to solve it. So I need to isolate t. I need to isolate t. Calculator in the room. Things are just all of a sudden connecting. I'm going to change that into a decimal just to make myself feel more comfortable. Okay, how do I get t by itself? Ah, yes, inverse cosine. So essentially, I'm bringing this to the other side, and it's going to be cos -1, 0.125. 6t. I'm going to times both sides by 6 because I want t by itself. So I'm going to times that by 6, and then I'm going to divide it by pi. We'll round to 2 decimal places. So 2.76 hours after high tide is the first time, everybody have that before I start scrolling up. Is the first time I see 13. So this coordinate pair right here is 2 point, what did I say, what, 76? 76 is my x value, and 13. So 2.76 hours after high tide, the water level has dropped below, will drop below 13 meters. Can't have that. But like I said, these are symmetrical. So from 0 hours, from high tide, for 2.76 hours, that boat can dock. The question asks not when, the question is asked when. It says determine the number of hours per cycle the ocean liner can dock safely. So if I know this distance here is 2.76, what do I know about this distance right here? It's the exact same. Because they're symmetrical, and it's beautiful, and life is good. So if I know that this distance here is 2.76, I know this distance here is also 2.76. So how many hours can that ocean liner dock safely? You got it. 5.1. Okay. So now, what is it telling me? It's saying if the minimum depth of birth occurs at 6 hours, determine the depth, I should say, say of the water? Does it say at the water? Should say of the water. At what of the times is the water level at a minimum? So all this is saying is that at 6 hours, I'm at a minimum. When's the next time we're going to see a minimum? When's the next time the water's at a minimum? Look at your graph. One full period away, right? 18 hours. So for part B, it would be our 6 hours plus our period gives us 18 hours. After the high tide, we'll be at another minimum. Does that make sense? There's one. So kind of you have to unpack what the question's asking you. This didn't take any super duper math. This kind of took some super duper math. Where's our first minimum? Right? And it says it in the question. It says the minimum depth occurs at 6 hours. And then it asks, what other times would the water level be at the minimum? Okay. All right, another one to do. Is there any shift in this graph? Are there any brackets here? No, so there's no shift. And this is another cosine graph, so we're starting at a maximum. All right, so I think I wrote my D down wrong. I did. Pardon? B is 13. Okay, so if my period is, sorry, you're right, I got this wrong, I was doing my period. Thanks. The period is 13, this is 2 pi over 13. What I really need is my period. So where's my something's happening point? 13 divided by 4. So now all of a sudden we're not dealing with a nice graph. 3.25. This is ugly. This isn't as pretty now, right? So how are we going to do increments? Any suggestions? You want to go by 3.25? Yeah? Well, I think we can do that here. Well, how well does that work out today? If you start at 0, right? If you start at 0, then you're golden. But if you don't start at 0, then all of a sudden, that's when I did the common denominators last time. That was a lot. That was a lot of math. Okay, increments on the y. Anybody want to help? Anybody? Help? The increments? We got it? Thanks. So, like, if you go up by ones, that's kind of going to suck. I need to start it if my median is at 3.7. What's my maximum? 4.3. What's my minimum? 3.1. Yeah, you think so? We can do that. How do we do that? Did you guys know about broken lines? You put like a sideways V. What? And all it's saying is that this is crunched in here, and then the increments will change on the way up. You can only do it once. It's called a broken line, and it just indicates that it's kind of compressed. So 3.2, 3.3, 3.4, 3.5. I'm running out of room. This isn't going to work. So can't do every second one, got to do every one. This would be 3.3, 3.5, 3.7, 3.9, 4.1. So minimum you said was at 3.1. Where's my median? 3.7. So not finished yet. 4.3 and 4.5. So 4.3 was my max. So looking at this, these look about the same spacing. This way you can kind of tell you've got some sort of a plan happening. Okay, so it's a cosine graph and it has no shift. So where's 0 going to start at? Maximum. And then 3.25, we're going to be at a median. 6.5, we're going to be at a minimum. 9.75, back to a median. And at 13, we're going to be back to a max. Now it asked for 2 cycles. So this is my first cycle. And it asked for 2 cycles, so I'm going to keep going. How come this one I didn't put an arrow backwards? This graph is pretty specific. It says graph the function for 2 cycles, starting at t equals 0. It gave me my starting point. And so I have that, just that dot there. This will continue on, but this side won't. What's the period? We did this. Period's what? 13 pink elephants. 13 hours. A boat requires a minimum of 3.5 meters of water to launch safely. How many hours per cycle can a boat launch safely? A lot. So that's right here. So it could launch safely in any of this water. That will also happen over here as well. Okay, I'm going to let you guys do the math correctly, which I hope I did. I got T is equal to 3.95 hours, but there's something beautiful about waves. It's symmetrical, so that's going to occur here as well. So I'm going to times that by 2, and it can dock safely for 7.91 hours. I rounded this to right here, but I didn't round it until my final answer in the calculator. What does D ask us? What is the depth of the water at 7 hours? Is 7 a number on this increment scale? No. So we have to do some math. You just put in the 7 for T. Simple algebra. So part D, I'm looking for the height at 7 hours. So 0.6 cos 2 pi over 13 times 7 hours plus 3.7. Calculator in radians or degrees? Yeah, I think so. That makes me nervous. What? It's crazy. Okay, so here's my question. At 6.5 hours, I'm at 3.1. Where do you anticipate 7 hours? Do you anticipate it close to 3.1 or closer to 3.7? Closer to 3.1. That's only a half an hour difference here. That's a 3.25 hour difference there. When I did this, I got height to be 3.11 meters. Oh, 3.12. Am I rounding? Does anybody else get that? Yeah, that's what I got. Okay. So that's that. We got 10 minutes to talk about the quiz. I'm going to hand them back. Exempted. But how are you going to learn for your test that's going to be tomorrow?